At first glance, it looks and feels just like any ordinary glass you might find in your home or office. Smooth, transparent, and seemingly delicate, it invites you to reach out and touch its cool surface. But beneath that familiar exterior lies a secret. This glass can actually stop a bullet in its tracks. We usually think of glass as fragile, something that shatters at the slightest impact or a careless knock. Yet, bulletproof glass stands up to gunfire, a feat that seems to defy logic and everything we know about glass. It's a beautiful contradiction where raw, destructive power meets the brilliance of human engineering and innovation. Imagine it, a bullet traveling at over 1,000 feet per second, a tiny missile of metal, slams into what looks like a simple, clear pane. Instead of shattering into dangerous shards, the glass erupts in a spiderweb of cracks but miraculously holds firm, refusing to give way. It absorbs a force that would instantly obliterate ordinary glass, turning a deadly impact into a contained event. This isn't a movie effect or a trick of the camera. It's the result of real-world material science and years of research. The secret isn't just about making the glass thicker. You can't simply stack up a window until it's a foot thick and expect it to work. The real genius is hidden in the invisible details, a composite of different materials, each one chosen for a specific job. Think of it as a multi-layered sandwich, where every layer, whether glass or plastic, plays a crucial role in stopping the bullet. The tough outer layers take the initial hit, slowing the bullet and spreading out its energy. The inner layers, often made of flexible plastics, absorb and distribute the remaining energy, preventing penetration. This clever combination of brittle and flexible materials is what gives bulletproof glass its remarkable strength and resilience. It's not just glass. It's a marvel of engineering, meticulously designed to stop the seemingly unstoppable. Each layer is carefully selected for its unique properties, from hardness to flexibility to how it bonds with its neighbors. Together, these layers form a team that's far stronger than any single material could ever be on its own. The result is a clear barrier that can withstand incredible forces, protecting people and property from harm. It's a testament to human ingenuity, the power of science, and our drive to make the world a safer place. Bulletproof glass is where transparency meets toughness, and where safety doesn't have to come at the cost of beauty. And it all starts with understanding the science behind how to make glass fight back, turning a fragile material into a silent guardian. Let's clear up a common myth. Bulletproof glass isn't just a thicker, heavier version of regular glass. It's far more sophisticated than simply stacking up more material. If you tried to use a single thick pane, you'd quickly run into problems. Not only would it be extremely heavy and difficult to handle, but it would also be brittle and prone to shattering under force. When a bullet strikes, the energy is focused into a tiny area, causing ordinary glass to explode into dangerous shards. The real secret is lamination, building a composite structure made of alternating layers of glass and polycarbonate, a process that transforms fragile glass into a powerful barrier. The outermost layer is specially hardened glass, designed to face the threat and take the initial impact. Behind that, you'll find polycarbonate, a tough, flexible plastic that's engineered to absorb and disperse energy, preventing penetration. These layers are stacked like a protective lasagna, each one serving a unique purpose in stopping and slowing down projectiles. The number and thickness of these layers can be customized depending on the level of threat, whether it's a small handgun or a high-powered rifle. The glass layers are intentionally hard and brittle, designed to crack and spread out the bullet's force, blunting its tip and slowing it down. Polycarbonate is the resilient hero of the system, flexing and stretching to catch the deformed bullet, trapping it safely inside. This 1-2 punch, glass to shatter and slow, polycarbonate to absorb and stop, creates a synergy that makes bulletproof glass so effective. Polycarbonate's strength and clarity make it ideal for more than just security. It's used in everything from hockey visors to eyeglass lenses, protecting eyes and faces every day. By combining these materials, bulletproof glass panels can be made much thinner and lighter than a solid glass slab of the same strength, making them practical for vehicles and buildings. Each layer works in harmony, transforming what would be a fragile material into a formidable shield that can withstand incredible force. It's a masterclass in material science, blending chemistry, physics, and engineering to create something truly remarkable. That's how bulletproof glass turns fragility into strength, by using science and smart design to protect what matters most. Let's break down what happens step by step when a bullet slams into bulletproof glass. It's not just a single sheet standing in the way, there's a whole team of layers, each with a unique job, working together to stop the threat. The outermost layer is made of regular glass, but it's designed to be brittle. When the bullet hits, this layer shatters dramatically, absorbing a huge amount of the bullet's initial energy in the process. This shattering isn't a sign of failure. It's actually the first crucial step in stopping the bullet's momentum. The broken glass acts like a cushion, spreading out the force and slowing the projectile down. As the bullet pushes through, the shattered glass also flattens and deforms it, making it less aerodynamic and less able to penetrate further. This deformation is key to reducing the bullet's power. Next, the bullet meets a tough polycarbonate layer. Think of this as a super strong, flexible trampoline. Instead of breaking, it bends and flexes, soaking up even more energy from the bullet. Polycarbonate is excellent at absorbing and spreading out the force of the impact. The energy from the bullet is distributed over a much wider area, which dramatically reduces its intensity and makes it even harder for the bullet to keep moving forward. This process repeats with multiple alternating layers of glass and polycarbonate. Each layer has a specific role. The glass shatters and absorbs. The polycarbonate flexes and spreads the force. With every layer the bullet passes through, it loses more speed and energy, like trying to run through a series of increasingly thick walls. Eventually, the bullet is slowed to a stop. The innermost layer is usually a tough polycarbonate sheet, often coated with a special anti-spall film. This film is designed to catch any tiny fragments that might break off during impact. Spall refers to those dangerous little shards or fragments that can break off the back of the panel when it's hit. Without protection, these could still cause injury. The final polycarbonate layer, reinforced with the anti-spall film, acts as a net, catching both the bullet and any debris, making sure nothing harmful gets through to the other side. This means the surface behind the glass stays safe and undamaged, even after a powerful impact. It's all about keeping people and valuables protected. Every single layer has a job to do: shatter, absorb, slow, and finally stop the bullet. It's a carefully coordinated defense system. The result? A panel that can withstand not just one, but multiple impacts, holding strong even under repeated attack. This is the result of years of engineering and testing, with every layer fine-tuned for maximum protection and reliability. That's how bulletproof glass stands guard, protecting what matters most, whether it's people, property, or priceless objects. It's science and engineering in action, every single time a bullet strikes. Polycarbonate is the real muscle behind bulletproof glass. Glass is the face, but polycarbonate does the heavy lifting. Without it, glass would just shatter layer by layer. Polycarbonate's long, tangled molecules let it stretch and absorb energy. It bends and deforms, stopping bullets by distributing force. Think of it as a net catching a punch, not a wall breaking. This flexibility is what sets it apart from glass. Polycarbonate is lightweight, optically clear, and incredibly strong. Using only glass would make panels absurdly thick and heavy. Polycarbonate allows for thinner, lighter, and more effective protection. It's the perfect partner for glass, combining flexibility and strength. Together, they create a composite far greater than the sum of its parts. Making bulletproof glass is a feat of engineering. Layers of glass and polycarbonate are meticulously cleaned and stacked. A thin interlayer film acts as glue between each sheet. The stack is sealed in a vacuum bag to remove air and prevent contamination. Then, it's placed in an autoclave, a high-pressure, high-temperature oven. Heat softens the inner layers, and pressure fuses everything into a single panel. The result is a clear, strong composite with no weak points. What starts as separate sheets becomes a unified shield. This process ensures optical clarity and maximum strength. That's how a stack of materials becomes super glass. Building bulletproof glass is one thing. Proving it works is another. Testing follows strict standards like those from the National Institute of Justice. Panels are mounted and shot at with specific bullets at set speeds. High-speed cameras and sensors capture every detail. To pass, the glass must stop the bullet and prevent dangerous spalling. Multiple shots are fired in tight patterns to test durability. Panels must withstand repeated impacts, not just a single shot. The results determine where the glass can be used: banks, vehicles, or military. Thicker, heavier panels are needed for higher threats. Standardized testing removes guesswork and ensures safety. Only panels that pass these brutal tests make the cut. That's how we know bulletproof glass is ready for the real world. Once you know what to look for, bulletproof glass is everywhere. Banks, gas stations, and government buildings use it to protect people daily. Armored cars for VIPs and military vehicles rely on thick, multi-layered panels. Even jewelry stores and high-end boutiques use laminated glass to prevent smash-and-grab thefts. Prisons and psychiatric facilities use it for secure observation windows. In hurricane zones, laminated glass protects buildings from flying debris. The same principles apply glass cracks, but the plastic layer holds everything together. From limousines to storefronts, this technology quietly keeps us safe. It's a hidden shield in our everyday world. The glass and plastic sandwich is everywhere, making life safer. Bulletproof glass is silent protection, always on guard. The secret to bulletproof glass is energy distribution. Regular glass is brittle, strong under compression, weak under tension. A bullet's energy shatters it instantly. Bulletproof glass, by contrast, is a ductile system. The outer glass shatters, but the polycarbonate behind it flexes. This layer bends inward, spreading the force over a wide area. It's like being pushed with a palm instead of poked with a needle. Each layer absorbs and distributes more energy, stopping the bullet. Even after multiple hits, the panel holds together. Spiderweb cracks stay localized thanks to the flexible layers. Polycarbonate acts as an elastic backbone for the brittle glass. The result, a panel that bends, not breaks. That's the genius of composite materials. Even the best bulletproof glass isn't unbreakable. Cracks and bulges show it's doing its job, absorbing energy and stopping bullets. Engineers are always improving materials, making panels lighter and stronger. Some new designs can even self-heal minor damage. The future is even more exciting: transparent aluminum, or Elan. Elan is a ceramic that's optically clear and harder than glass or polycarbonate. It's lighter and stronger, but currently expensive to produce. Used in military and aerospace, it could one day protect cars and buildings. Imagine windows as clear as glass, but as strong as metal. Science keeps pushing the limits of what's possible. The future of transparent armor is just beginning. Kind of amazing, right? If you learned something new or just love this kind of tech, give us a like and hit subscribe to keep your curiosity sharp.